And then we'll deal with the ones that are actually going to be similar to the test we're taking on Thursday. How do I factor number 1? Tell me the two factors. 4 and negative 8. I heard it from you first, Jax. Negative 8 plus 4 is negative 4. 4 times negative 8 is negative 32. Perfect. If these equations were set equal to 0, we would know our two zeros. Where would our two zeros be? Very good. Okay, number 2, another easy factor. Negative 11 and 6. Negative 11 plus 6 is negative 5. Negative 11 times 6 is negative 66. Perfect. If we wanted to know, and you can have your point page. If we wanted to know the zeros on this one. Okay. Good, good, good. Okay, number 13, another easy factor. Thank you, Gilberto. I heard you first. I think Paige was saying it too, but, we'll give you a chance. 8 plus 5 is 13. 8 times 5 is 40. That's perfect. And where are my two zeros? Yes. And then last but not least, number 4, which is probably the most similar to the ones we're talking about today. Take out a negative y. So y squared plus 5y plus 6. Factor y squared plus 5y plus 6. It's still an easy factor. One and 6 would add to 7. 1 and negative 5 would add to negative 4. 2 and 3, yes, dear. 2 times 3 is 6. 2 plus 3 is 5, yes. But hey, you were thinking you were on the right track. We were going to come up with it. Gilberto eventually did, so he can add the point. But yes, you're on the right track. Do not break my heart. Tell me the zeros. Okay. And I'm going to give Paige the point for that. She got them all out. Although, Jax did get out the one I was most concerned about, the 0. Yes, y plus 2, so the negative 2. Y plus 3, so the negative 3. If you leave out that 0, you've got a problem. Plus, if you leave out that 0, I bet you said the degree was 2, and clearly this is a degree 3. So you've already messed up not only figuring out the zeros, but you messed up the graph, and hence why a 10-question test can be suddenly dangerous. Okay, let's look at your notes from yesterday if there are no questions about this. We were in a new packet. We did the first 4 problems, and then we called it a day. Although we did circle 5, 8, and 11. Can someone tell me why we circled those? Paige gets the point. 5, 8, and 11 were not equal to 0. And we have to set them equal to 0. Okay, I want to do 5 and 6 first. I'm going to go ahead and set 5 equal to 0. Even though 5 is now equal to 0, I want to start with number 6. Are there any thoughts as to why number 6 first? Well, yeah, it's a perfect cube, but if you look at the title for those 2 questions, it says sum and difference of cubes. So they're all perfect cubes. Well, so is number 5. I've already rewritten it. That's what I'm going for. The leading coefficient is just a 1 on this one, so it makes it a little easier. The leading coefficient being an 8 on this one's going to make it a little more difficult. So that's why we're going to start with 6. 6 we should already be able to do on our own. Because I've told you, like 5 times, that sum and difference of cubes is going to be on the next test. Yet first period did not believe me. So they broke my heart this morning. Maybe you won't. What cubed is 64? Thank you. There's an acronym that's supposed to help us with someone. Yes, you can have your point. It's supposed to help us with sum and difference of cubes, and that was SOAP. Remember, it was the same sign, the opposite sign, and then always positive. So in our case, our sign is a plus. So we're going to have same sign, Opposite sign, always positive. We just got to figure out the numbers and variables that go in the different blanks. Can someone tell me all the things? Okay, keep going, Gilberto. Are you done? Oh. Okay. And that's about what happened first period, hence my sadness. It's x and 4, yes. Then x squared, 4 squared's on the end, 4 times x in the middle. We've been over this a couple times. This pattern shit, I know you sleep at night and stuff, I get that. But this pattern keeps going on, so if you've yet to get it down about how it's always x, 4, that one squared, those 2 times together in the middle, then oh goodness, you got a problem. We're not completely done with this problem. We're gonna come back to it in a second. Let's go ahead and figure out how to factor number 5. So number 5 is a little harder because of that 8 in front. It's still the sum or difference of cubes. In this case, it's the minus sign, it's the difference of cubes. So I know something cubed is 27. That's 3. But I also know that something cubed is 8x to the third. And what is that? It's 2x, and you can have a point. X to the third, duh. 2 to the third is 8, so this perfectly works out. So seriously, well, I gotta think of soap first before I go crazy. Same sign would be a minus, opposite sign would be a plus, always positive. But seriously, the blanks are still the same process. It's gonna be a 2x minus 3. On the end, 3 squared is 9. Over here, 2x squared, well, that's gonna be 2 squared is 4. X squared is x squared. And then in the middle, those two multiply together. 3 times 2x is 6x. So it looked more complicated, but it's still the exact same process. Just for kicks and giggles, because, you know, that was your first time to do that one, and I'm telling you, there's one with a leading coefficient of a 1 on the test, but the other one on the test that's the sum or difference of cubes is a leading coefficient like an 8 or a 27 or a 64 or some other perfect cube. So it wouldn't kill us to try one more. So I'm going to write myself one more problem. What if we had 125 x to the third minus 64? Okay, what cubed? 5x would give us the 125x cubed. Perfect. And what cubed gives us the 64? Yes, perfect. So can you be brave since you knew all that and fill this in? Okay, hold on. Let me soap it out. I forgot. So same sign, opposite sign, always positive. Okay, and then Gilberto said 5x minus 4. 25x squared plus what? You multiply those two together. So multiply together would be 20x, and then on the ends it'd be 16 because of 4 squared. So it's still plugging in those two, squaring this guy. So 5 squared is 25, x squared is x squared. On the end, 4 squared is 16. In the middle, I multiplied 5x and 4 and got 20x. So it's the same process, if only you know the process. Soap almost helps get you there, just not quite all the way there. Now, sadly, you and I have not actually, while we factored, we've not actually reached solutions. That's kind of the whole point, because you and I are trying to graph and figure out zeros and stuff. So we're not done with any of our 3 problems we just worked, because we've yet to find answers. Okay, so let's start with the one we're currently on. I have to set each of these equal to 0. So I'll do 5x minus 4 equal to 0. And what do I end up getting for x? Thank you, dear, and you can have a point. Okay, that is a real number. If I asked Paige to graph that, she could actually go to 4/5 on the x-axis, put a dot, and eventually she would make sure her graph crossed through that dot. What are we going to do with this 25x squared plus 20x plus 16? Sadly, and I'm with you, and I would try and try and try, but sadly this is not factorable. Okay, so all we're going to do for this test, if it's not factorable, that means it doesn't have two real answers. Instead, it has two imaginary answers. So all you have to do is, underneath that part, put imaginary numbers, so at least then you acknowledge it. We discussed yesterday how imaginary numbers affect our graph, or how they don't affect our graph, maybe I should say. What's the deal with imaginary numbers and graphing? They don't cross the x-axis. So our graph is only going to cross the x-axis once, and is at 4/5. We have a snake, because it's x cubed, it's positively in coefficient. So I've got this snake going uphill, it only crosses at 4/5. Doesn't cross anywhere else because it's imaginary business. Okay, same thing's going to happen on this one. I'm going to have two imaginary numbers. Sadly, every single time with the difference of cubes, the trinomial part is going to give you two imaginary solutions. And then I've got one real number, and it is, yes, dear. So if I graph number 6, still a snake, still going uphill. The only place it crosses is at -4 because of that imaginary part. Okay, we'll handle number 5 and then we'll nerd it out for half a second, although I promise you this is sufficient for the test. As long as you acknowledge the real solution and that this part's not factorable and you've got some imaginary numbers, you don't even have to try to find those imaginary numbers when it's a sum or difference of cubes problem. Now, the other problems we worked today, we're actually going to find the answers, like plus or minus 3i answers, the way we did yesterday. But for this, it would take too much time and too much thought, so we're just going to let it go. As long as Paige puts imaginary numbers with the trinomial, and she solves the binomial to get the real 0, I'm going to give her all her points. Okay, but I'm a nerd, and I like to know when the nerds are with me. You don't have to be a nerd, and my goodness, first period can't come up with it, and it doesn't break my heart if you don't come up with it. I've had years and years of math class. It's the only reason I know the answer to this question. If we were determined to find the imaginary answers, and we can't factor it, what could we use to find the imaginary answers? We're determined. I gotta know. I just got to know. Something with an I. Can't just take the square root. How do I solve 4x squared plus 6x plus 9 if we can't factor it? We actually covered it back in chapter 4 when we were dealing with quadratic functions. Every class has made you do it, the past 2 years at least. And yet we never connect the dots on when it might be useful. It's okay. It's the quadratic formula. Suddenly that thing's supposed to be useful. I don't know how to factor that. If I use that quadratic formula, I would actually know the answers. Do you have to find the answers for this test? No. Do I expect Paige to sit over there and do the negative b plus or minus all that jazz again today? No. But if she was determined, she could figure out the answers by using the quadratic formula. Okay, I hate to break your heart, but you realize today is Tuesday. The test is Thursday. Clearly, we need something to do on Wednesday, which is going to be the next page. Look at the back of this page of notes. See how there are 18 problems? Those are yours. How many of those problems are sum or difference of cubes? You're assuming the bottoms are and they're not. Look for cube numbers. How many of those are sum and difference of cubes? No. Sean wouldn't say for the day. How many on the back are 7 different cubes? It's just the top 6.
Okay.
It's just the top 6. So maybe you need to make a note of that. The top 6 are 7 difference of cubes. Maybe if you're the ones who were thinking 12, you need to make a note to yourself. 1 through 6 are the cubes. Okay, so tomorrow at the end of class, I sure would love to see this done completely. It's okay if I don't, but you need to have it done and turned in on Thursday, the day of the test. I'm actually going to post the key to it Wednesday night, but what's the point of Justice looking at the key if Justice has never practiced himself? Justice is the one taking the test, not Miss Compton. So Justice is going to practice because he's a good student. But for my non-good students, the answer key will be posted Wednesday night. So how do you not turn this in on Thursday is beyond me. Okay, are there any questions about the sum or difference of cubes? Okay, we're going to do the cortex section, and then if it's okay with you, I think I'll go ahead and let you work, because I just think if I say the cubes, the cortex, and the factor in my grouping today, it'll just be too many things. So I think we'll save the last part for tomorrow. Okay, we'll do the cortex, though. Let's start with number 7. 7 is actually really easy, and it's terribly annoying. Someone tell me what they think we should do on number 7. XY.
X squared.
Okay, Jax had it first, so we're going to give Jax a point. X squared, we're left with x squared plus 10x plus 21, and we set that equal to 0. And suddenly this problem is a whole lot easier. I need 2 things that add to 10 and multiply to 21. Yes, dear. Yes, dear, and get your point. X plus 7, x plus 3. And now I've got to think about my zeros. Tell me about the zeros. And if there was some note I would want to make to myself about one of those zeros, what would it be? Jax, your group can have another point. If there was a note I wanted to make to myself about those zeros, what would it be? One of those zeros. I need to make a note to myself because I want to do well on this test. Some of you missed it on the checkpoint. Yeah, say it, Angel.
That your x isn't 1, but it's 0.
X isn't 1, it's 0. Okay. There was something a lot of people missed on the checkpoint on the first problem that they had to go back and fix because they didn't acknowledge something. That's something they would need to acknowledge in this problem as well. Say it again. Yes, and you can have your point. There's a 2 right there, so that 0 has a multiplicity of 2. What does that mean about its graph? What's going to happen at 0? Yes, it's going to have a little bounce at 0. Agreed. So if we don't make that note, Angel might not put that bounce. Suddenly she knew what she was doing graphing, but she's messed up because she didn't think about that multiplicity. Okay, are there any questions on 7? 8's a little harder, but we've actually done it in Math Workshop at least 2 times. So, maybe not recently, but I recall doing it with you before. Unless I've been doing math in my sleep, which I doubt. Okay, why is this one harder? Yeah, I did have to move it around and set it equal to 0. That's true.
Oh yeah, we need a 0 x or do not need that.
It's an x to the 4th power. Why was number 7 a little easier from this point forward? There was a GCF we could take out. There's no GCF in this one. But we still need to factor it. We're not just going to call it a day. Does anyone recall what I've done in the past when it's an x to the 4th and I need to factor? It's okay. I use substitution. I say y is equal to x squared. And so my whole problem changes to y squared plus 11y plus 18 equal to 0. And now why it might seem strange that I did this, suddenly I'm at that green line. When there are no x to the fourth, I'm only dealing with squared people. I'm back to easy factoring because I just need something that adds to 11 and multiplies to 18. No big deal. I can do that. I can handle this line, and I can figure out my answers. But when I was back here, I did not see it. No, I have to substitute in order to figure this out. Okay, so what adds to 11 and multiplies to 18? 2 and 9. Gilberto, get your point. Okay, are there any questions about the green? So anytime I see a fourth problem, like number 8, it's 3 terms, there's nothing I can factor out, that's when I start thinking about substituting. And all I'm doing is making it into a 2 problem, a y squared problem, because that's easy factoring and I can handle that. Okay, but Paige is in a hurry because we all are in life. And she says her answers are -9 and -2. And she is wrong. Why would she be wrong? Yeah, we can't stay with these y's. We got to go back to x's. Perfect, Paige. You can have your point. Gilberto, I don't know what you were saying. Was it just as genius? Do you deserve a point? Okay. I appreciate your honesty. Okay, so we had said y was x squared, so where we had a y, I put an x squared. So literally, I did the 2 green lines to help me go from this brown line to this brown line. But I don't know about you. I don't think I would have figured out this brown line from that brown if I hadn't done my substitution. I need the substitution to help me think it through with easy factoring. Okay, but I still need to know my answers. So I'm going to have to set each of these equal to 0. So if I do x squared plus 9 equal to 0, I get x squared equals -9. And then what happens? Okay, if I take the square root, I get x equals what? Is it the square root of 3? It's just 3i. So if you're not following that logic, then let's do it one step at a time. It's plus or minus. We've got that square root of 9. We're going to throw in an I. That way that negative under the square root goes away. Hey, I know the square root of 9, it's 3. So if you were already here to plus or minus 3i, good for you. The other problem, sadly, does not end up being that pretty. Because unlike 9, 2 is not a perfect square. So x squared equals -2. I get x equals plus or minus the square root of, yes, 2i. And I need to put my I outside the house. So let me write that one again. I is not in the house. So sad day. We have 4 imaginary solutions. And that just stinks. And while you don't have to do this on the test, my gosh, what is the point in life if we don't relate this back to the graph? So we had x to the 4th, and it had a positive leading coefficient. So what was I anticipating the graph to look like? A W. Okay, I have imaginary solutions, which means I don't cross the x-axis at all. So literally my W is just happening up in space. 4, you can have another point. Now, did you have to know that for this next test? No. What on the earth is Katie doing figuring out these imaginary answers and then graphing if she's not figuring out why they correlate? I just don't know. Okay. Do you want me to go ahead and do the last part so all you have to do tomorrow is work? Or would you like to just go ahead and work today? Okay, so look at the next page. We just did the ones that were to the 4th power. So what problems are those? It starts at 7 and goes to where? 12. So you know how to do 7 through 12. So do you want to work on 1 through 12 now and I'll finish the last bit tomorrow? Or do you want me to power through? I can do whatever you want. Right? You alright? Okay, cool. So we know how to do everything except the bottom, which is grouping, which is normally your favorite in life. We like grouping. Grouping just like usual. Put them in groups. This part's probably the easiest part just because you and I practice grouping so much. What can I pull out of the first group? X. Thank you. You can have a point. So I have x squared plus 3. Thank you. I knew I'd done something wrong. You can have a point for that. It's x. That's a 2 that I've covered up. I can pull out an x squared, and I'm left with an x plus 3. I knew I was getting sad because my second group wasn't matching. What can I pull out of the second group? I'm going to pull out a 4, and I'm left with an x plus 3. And now I'm happy because my groups match. So I've got x squared plus 4 and x plus 3. Yay, my groups matched. Now, side day, I've got to figure out the answers. One of them is an easy answer, and the other one's going to take a little work. Yes, this one is easy. It's just x plus 3 equals 0, so x equals negative 3. That one was easy. Agreed. We've got that real number. Sadly, this one's going to end up being some imaginary junk. We still got to do it, though. X squared plus 4 equal to 0. Yes, bless you. X squared equals negative 4. When I take the square root, I get x equals plus or minus 2i. Thank you, Jack. So you can have a point. So I've got 2 imaginary ones and 1 real number solution. Perfect. So we factored, then we set each factor equal to 0, and it's okay that 2 of them were imaginary. We're okay with that. Are there any questions about number 9? Then let's handle number 10. Still grouping. What can I pull out of the first group? If I pull out an x squared, I'm left with a 2x minus 1. What can I pull out of the second group? If I pull out it needs to be a negative 3. So I have 2x minus 1. So my 2 groups are x squared minus 3, 2x minus 1, and they equal 0. Are there any questions to that point? I'm pretty positive most people in the room can handle that. The only issue is now finding our answers. What is the real answer? Yes, 2x minus 1 equals 0. You can have a point. So x equals 1/2. That is our one real number answer. Sadly, the other is going to end up being an imaginary stuff. Oh, where is it? Not a negative under the square root. Perfect. So it was x squared minus 3 equal to 0. We get x squared equals to 3. When I take the square root of both sides, my answer is what? Plus or minus square root of 3. And we're done. But sadly, that's still a real number. Until we throw in the I, because there was a negative under the radical, it's still a real number. It's somewhere between, well, square root of 4 is 2, so it's really close to 2. So basically, we are hitting the graph at 0.5, something close to 2, and something close to negative 2. So if we graph this, it really would cross the x-axis 3 times. Okay, last but not least, are there any questions about 10? Last but not least, we have 11. I'm going to move that 9 over. So x to the third plus x squared minus 9x minus 9 equals 0. I'm still going to use grouping. What can I pull out of that first group? Okay, if I pull out an x squared, I'm left with an x plus 1. What do I pull out of the second group? I got to pull out a negative 9, and then I'm left with an x plus 1. So my groups are x squared minus 9 and x plus 1. Perfect. And then I'm super excited about this one. Okay, so I hear Jax and page, so I'm going to give them a point. But, so x plus 1 equals negative 1, but they're not completely correct. They got the negative 1. And they got the 3, but they're not quite right, are they? It's plus or minus 3. We took the square root of both sides. We got plus or minus 3. And you're like, Miss Compton, how am I supposed to remember that? And it's literally because my exponent, my degree, Lord Jesus, you know that term now. Why can't I use it? My degree was 3. So I was supposed to have 3 answers. When you said negative 1 and 3, you only gave me 2 answers. There's supposed to be 3 answers because the degree is 3. Okay, now you know how to do the whole entire backside, which is all your. We'll do math workshop tomorrow, and then I promise I won't talk. You can just work on that the entire time. Yes. If you didn't finish your checkpoint yesterday, my goodness, get it together. I probably typed in a 0.